Talk about algebraic representations using tables. So before we do that, let's go back over order operations. Lindsay and Diego are arguing over the following problem. Lindsay says it is correct. Diego says it is wrong. Which student is correct? Or who's smarter here? So let's look at this problem. So 12 divided by 3 plus 4 minus 24 divided by 3 times 8. In order operations, again, is gemdas. More like Gangan style. So anyway, gemdas is grouping. G is for grouping symbol. There are none. E is for exponents. There are none. M is for multiplication, division from left to right. I see a division here. I see a multiplication division from left to right. So what is 12 divided by 3? 4. What is this division multiplication from left to right? 24 divided by 3 is 8. 8 times 8 is 64. Now it's adding and subtracting from left to right. So 4 plus 4 is 8 minus 64. Oh no! We learned this before. It's subtracting integers. Change the minus sign. Change the minus to a plus. Change the sign to the next. And then all you do is add them up as if they were a plus. There are 64 negatives and 8 positive. There are 53 more negatives. So it is wrong. So Diego says it is wrong. So Diego did a better job. The answer is negative 53. All right. So in algebraic representation, we're going to be using expression. You're going to hear me using the word expression for the next 3 lessons. An expression is like a math sentence without an equal sign. It's just like, imagine like 2 plus 2, 5 times 7, 12 divided by 4, n plus 5. We don't know what that missing n is yet. G minus 6. Just a sentence, no equal sign. We don't know its value yet. So an expression has numbers, symbols, and operators. They are grouped together to show the value of something. Example, 2 times 3 is an expression. Notice how there is no equality sign. The next word we're going to learn is a variable. A variable, you're going to be hearing this word over and over. A variable is like a symbol, a letter that really represents a number. Usually it's X or Y. Sometimes use the letter N. For example, if x plus 2 equals 6 in this equation, x is the variable. So in an algebraic representation, the input value is known as the independent. The output, or y, is known as the dependent. In science class, you have talked about this a lot of time. For example, here is a graph. This is the x, this is the y. This is the independent variable, which is the x value. The dependent is the y. Why? So this depends on this. So you're going to be hearing me use the word depends throughout the lesson. So again, this is something you just need to memorize. So this is the independent one. This is the dependent for y. So before we begin, give me an example of an expression. And from it, can you give me, so for example, 2 plus 5. That is an expression. N plus 9. That is an expression. From this, are there any variables or letter that should represent a number? No. From this, are there any variable or number or letters that should represent a number? N is it. So let's put a situation where you need to hear about independent and dependent. This is a table. It shows a relationship between x and y. So you start with a 15. Something happened to this relationship and became a 3. This one had a 20, then it becomes an 8. Just as 25 becomes a 13. A 30 becomes 18, and a 35 becomes a 23. Can you list the independent quantities shown in the table? Ooh, independent is what again? Ooh, I can't remember. Independent is here. Dependent here. Oh, independent is x. So x. So the independent quantities are 15, 20, 25, 30, 35. In other words, they are the x values. Which numbers in the table represent dependent? It's the y values, 3, 8, 13, 18, 23. Now, this is where it gets hard. Can you write an expression to show the relationship between x and y? What is happening to x in order to become a y? What is happening to this 20 to become an 8? Well, first of all, I know it's going down. Is it being subtracted or is it being divided? Let's see. If I subtract 12 from this, I get 3. If I subtract 12 from 20, I get 8. Oh, if I subtract 12 from 25, subtract 12, subtract 12. So we are subtracting 12 from what? Because it said write an expression. We are subtracting 12 from the number they gave us, which is the x. So it's x minus 12. So if this was x, you're taking away 12 from that letter x. So given an independent number, an x value number, you take away 12 to get the y. In subsequent lessons, you are going to be required to write it this way. X minus 12 equal y. For right now, I'm okay with this. You're taking 12 from the x values. But in subsequent lessons, you're going to say you're taking 12 from x value and it will eventually equal y, which is these values. So next one. This table shows the cost for student admission to AMC Theater. 1 ticket costs $5.75. 2 tickets cost $11.50. 3 tickets cost $17.25. 4 tickets cost $23. Which label describes the dependent quantities shown in this table? Which label describes the independent quantities from this table? The dependent would be the cost. So this is x, this is y. Which label best describes the independent quantities? The independent quantities would be the tickets. So again, if you're drawing a graph, independence here, dependence here. This is x, this is y. That's how I memorize it. Independent is x value, or the first values. So independent are the tickets and thing. So the price depends on the tickets. That's why this is dependent. To know the cost, you need to depends on how many tickets you buy. That's why this is dependent and this is independent. Now, can you write an expression to describe the relationship between C and T? What's happening to these ticket numbers to reach the cost? What are we doing here? Let's see. It looks like it's increasing. It looks like we're building it up. Is it building up through addition or building up through multiplication? Let's see. I think we're multiplying by 575. 1 ticket times 575 is 575. 2 tickets times 575 is 1150. Yes, we are multiplying by 575. So, describe the relationship. So if you have a number of tickets, you have to multiply it by 575. So it's 575 multiplied by the number of tickets. So it's 575 times t. Another way to write it is 575 per ticket. It costs 575 a ticket. So 575 for 2 tickets. 575 for 3 tickets. 575 for 4 tickets. So it's 575 a ticket. Will tell you how much it will cost. Next one. Number 5. Jenna babysits on weekends to earn spending money. She charges $5 per hour for each child. So one child costs $5. Create a table below to show the amount of money Jenna earns for one child in relation to the number of hours she works. Then graph the data, label the axis, write an expression to show the relationship. Oh, so many steps to do. If she babysits for 3 hours, it's 5, 5, 5, 15. 5, 5, 5, 5, 5, 25. 5, 5, 5, 5, 5, 5, 5. Must be a faster way of doing that. What if you multiply? 35. 5, 5, 5, 5, 5, 5, 5, 5, 5. Could I just do 9 groups of 5? That's 45. So, we created a table. Let's graph this. What will the independent be? The independent. It's the hours worked. Time is usually independent. Amount earned is the dependent. Why, you might say? The amount earned depends, that's why it's dependent, on how many hours you work. Now, how much money she's going to make depends how many hours she works. If she works little hours, she'll make less money. If she works a lot of hours, she'll make a lot of money. So scratch this. 1 hour, she makes $5. In 3 hours, she makes 15. In 5 hours, she makes 25. In 7 hours, she makes 35. In 9 hours, she makes 45. It's making a line, a linear line. Nice. Where's the next screen? Yes, here's the next screen. So which label best describes the dependent? The dependent is the amount earned. That is the y-axis. Which label best describes the independent quantities? That's the hours worked. And that is the x-axis. Can you write an expression to describe the relationship between H and E, hours and earned? What's happening here? What is happening to the hours worked to this one? Are we building it up, breaking it out? We look like we're building up. Or is it building up through multiplication or addition? I think it's building up through multiplication by 5. So we're multiplying by 5. That's the relationship. What are you multiplying 5 by? The number of hours she worked. So it's $5 times the number of hours she worked. Another way to say it is 5H. That's 5 groups of H's. So if she worked 2 hours, 5 times 2 is 2 hours is $10, or 5 groups of 2 hours would be 10. If she's working 9 hours, 5 times 9 is 45, or 5 groups of 9 is 45. So next one. In Mrs. Page's science class, students built ramps to race toy cars. They tested the hypothesis that the steepness of the ramp affects the distance the car traveled. Each group in the class was assigned a different height in inches to build the ramp. The data collected during the test is shown in the graph below. Based on the given information, label the x and y axis. So we need to find the independent. So this is independent. This is dependent. So we need to find the independent. So what do you think these numbers 1, 2, 3, 4, 5, 6 represent? Let's go back here. So it's the steepness of the ramp affects the distance. So this must be the steepness of the ramp. That's how much of an incline it goes up. Steepness of the ramp. And this must be the distance. So the distance is dependent upon the steepness of the ramp. That's why distance is dependent and this is independent, because the distance depends on the steepness, on how high the ramp is. If the ramp is has a huge incline like this, it would go much faster, it would be a longer distance. However, if it's just barely above the horizontal, it has a very low steepness, it would only go the distance will be very short. So what are the independent and dependent variables? The independent variables are the steepness. The dependent is the distance. Write a statement explaining the relationship. What is happening here? So from what I can tell, as the steepness increases, the distance increases. Is that really true? Let's go back and see this. Sorry for the handwriting. As the steepness keep going up, the distance keep going up. So in other words, say, you could also write, the distance increases, the steepness increases. So both of them are correct. So in this study, we talked about looking at a table, looking at a graph, can you distinguish between dependent and independent variables? Independent is the x-axis. Dependent is the y-axis. How do you know that these are dependent? So the way I do it is I read it and say which one depends on which. Then it makes it a dependent variable. So distance depends on the steepness of ramp. The other one dependent was the cost depends on how many movie tickets you buy. So that is it. Algebraic relationships.